Okay, with that, so we have in schedule another 40 minutes or so allocated for general discussion on the topics that were discussed in the breakout sessions. If there were any key uh, capabilities or key instruments that you noticed kind of maybe spanned a few of those of our discussions, but um, any key instruments or key capabilities that we either discussed and you want to highlight, or things that we didn't discuss that you want to make sure to call out. This is a good opportunity to do that. So I don't know if anybody wants to put comments in the chat or raise your hand and we can call on you if you have any conversations, any thoughts on the conversations that we had earlier. Now's a good chance. So I'll start things off by calling on Sean. Was there anything that you saw that or didn't see that you wish you had seen in some of the closing conversations or the summaries of the conversations that we had?
You talking about in the summaries from the other sessions?
Yeah, or in any of the discussions that we've had. So, I mean, we had talked about potentially mass of the instruments being one thing that would be really useful. Are there any other aspects that we didn't necessarily touch on as far as an ARM capability perspective that you wish we had or that we could talk about now?
Well, speaking for session 3, I feel like we covered a really good range of different capabilities. From what I understood from the other sessions, it seemed like there was a similar breadth of ideas. It seemed like there was pretty good diversity. I think maybe the only things we didn't really talk about were any kind of dynamic deployments of instruments, and maybe that would be, I don't know, in a different category, but for example, throwing an instrument. We didn't talk about something like that. But I think, from the discussion we had, we covered both a lot of specific use cases that I think will help. If there's more detail that we can put to specific use cases, that would be helpful, like knowing that I think we talked in general about putting out a seismic sensor array or a set of antennas for a RF observatory or those kinds of things, but we didn't speak to the actual scale. We didn't say we need to deploy 100 sensors that cover a square kilometer or something like that. So certainly if we can as a group come up with some quantifications that help put these things in more of a quantitative context, that would be great. It would help us.
Yeah, absolutely. We did, as you noted in your closing remarks, that I noted in mine, at least in the session, we do encourage people to continue to submit templates if the discussions today had inspired you to think about a specific instrument or even a class of instruments. It doesn't have to be a specific APXS system. It could be the class of APXS, like what specifics you might have on, or what specifications I should say that you might have on those types of instruments. We really do encourage you to go back to the template, and you don't have to fill the whole thing out, but even just some parts of it would be really helpful in scoping out what future arms and arm designs can be capable of. I put the link in the chat, a link in the chat, back to the original call for abstracts, and so there's a link in that um, on that page to the template, and you'd be welcome to reach out and send those to Sean and myself um, at pretty much at your leisure, but the sooner the better, to help feed some of these conversations and um, yeah, and yeah, you can submit additional input from the templates that you already submitted. You can resubmit if you'd like. It's just, we're just tracking the information that we're getting in and using it to go forward with ARM designs in general. So it's really helpful. And I see in the chat, so one of the submissions that we did receive was on the far side radio array. And so Jack, thank you for that extra information about how large an area we need to cover with those kinds of instruments, or the deployment of that capability. So that's really great and extensive. So rovers that can go over like long ways away for travel far, and that's true for other things too as well. I mean, we did this is specific to the ARM discussion rather than a rover or mobile asset in general, but we certainly do need rovers that are capable of traversing large distances to really address the key science objectives that we're discussing, like especially mapping out subsurface um, structure and lateral and vertical distribution of volatiles, in particular in the polar regions, but also to mineralogy and chemistry differences and traversing across geologic boundaries are often going to require quite extensive traverse capabilities. So keeping those kinds of things in mind too as you submit additional templates. But these templates, again, are very specific to the ARMS capability is what we're looking for, at least in this context.
Hey, Deborah.
Yes.
I actually have a couple comments about, I think, Sean, you might have brought this up a little while ago about the potential of having more than one arm and having, arms that actually can be there to aid in the measurements. So they're not necessarily part of the instrument, but, are there to either take off a dust cover, remove a lens, move an antenna, maybe scoop up a sample or something. I don't think I've really heard too much about anything like that. And I would imagine that that would be really useful because then that takes the pressure off of instrument developers, and instead of having to worry about getting at a subsurface sample or maintenance, for example. Is that something that people have been talking about? Is potentially having more than one arm um, for surface science?
I think, I guess to answer your question, thank you for that question. We are considering, and at least in session 3 for instrument deployment, we talked about maybe using a single robot arm, but with a tool changer so that we can deploy instruments, but also have a general purpose end effector or hold other tools. For example, if you wanted to bury an instrument, you could have the arm dig the hole and then place the instrument inside, using the tool changer to change out the different tools. Having a second robot is another possibility, but that's maybe a more mass expensive solution. But certainly, yeah, I think having either a standardized tool interface with a tool changer and multiple end effectors, or considering having multiple robots or having instruments mounted. We even talked about having instruments mounted to small rovers that get deployed by a robot, so that they're essentially they become mobile sensor platforms. So that there are a lot of possibilities out there, but I think that speaks back to the concept of having modular interfaces and modular standardized interfaces, so that we can build to those and have different providers build tools that the robot can use, and not just have a single turret that it has fixed instruments that are attached to it, or having even a simpler robot that only has a single type of end effector on it if we can avoid that. Thanks.
Yeah, thank you, Dina. That's great questions. Does anybody else have anything they'd like to add or anything they'd like to say?
I was part of session 3, and there was discussion on standard payload interfaces, and Sean, you kind of touched on this, that the dream is to have standards for payload developers to be used on and deployed for any rover or lander. And I mean, that's important from both the ARM and the payload development side of things. I'm just wondering, is the intent that will be developed and those standards will be written and flowed out, or from NASA, or is the intent that there would be leaning on industry, or perhaps developing it in conjunction with industry? Thanks.
I guess I'll take that one. So that's a good question, because in order to implement it, somebody has to promote it and enforce it. I think NASA is a little bit weary of mandating that you have to use a particular standard for some things versus others, especially when it comes to the commercial providers. But that having been said, that isn't out of the question. NASA does levy standards on many kinds of solicitations for projects. It just, in the commercial model, it gets complicated because commercial providers, their businesses and the instrument developers can, contract with them independent of NASA or, other customers. So it's tricky about enforcement. I think the CubeSat model is an interesting one to consider because it's sort of a standard. It's not completely a standard. And it came about and somewhat organically from universities and industry. I think ideally there'll be some kind of public-private, organization that's set up, and maybe an industry consortium that would coordinate standards amongst the various players. It's all still in development, but it's something that we're definitely talking about at NASA. How can we promote and ensure that the standards that we're promoting are beneficial to everyone and not interfering with the flexibility side of the equation in terms of providing technical solutions. But we definitely we see the need.
Thanks.
Heather, you're making some great points in the chat too, talking about, if we have, for example, drone capabilities or some sort of, I guess, a capability to move beyond the rover and beyond an arm could change the scope of some of the science that we could address, at least changing regions of accessibility. I don't know if that could spark any discussion as well, just kind of thinking even beyond an arm.
Yeah, that came up in some of our discussions earlier. It's the notion of, having an extension beyond the arm if you can have like a drone. So I mean that like was mentioned in here, that can enable us to get visuals directly inside of something that we wouldn't normally do. And then, like also mentioned, adding arms to that. So when it comes to actually deploying something, we can have cameras that can view it in different ways. And, we've got all kinds of other angles that we wouldn't normally have. If the cameras were fixed mounted onto a robotic arm, that's, that's more of a static thing. So when we add the kind of like separate modular kind of like drone concept, that gives us a whole bunch more flexibility with our actual like surface level, like optics and stuff. And so I feel like not being bound to one static kind of place opens up so many options for, where you would not have normally been able to have, gotten something down in there if you have a drone, or at least maybe even just some more flexible form of camera, like a snaked arm or something, instead of something that, is modeled after like a human arm.
Yeah, I think that speaks to the larger mobility discussion, and it did come up in session 3, where we talked about having the robot deploy small, micro rovers with sensors on. But in terms of having other mobility solutions, we talked about, very long range rovers. How do we cover very long range? And I mentioned the Intrepid study that NASA had recently published, looking at those longer range traverse capable rovers. NASA is also investing in the development of hopper landers, so smaller, kind of minimal landers that could deploy from a CLIPS lander and fly into a PSR or a lunar pit, to then take measurements and then ascend out of that back to a ridge line or a high point, so that the data could be transmitted back through the host lander. So we're definitely looking at concepts like that. And as folks said, ideally we would develop some kind of standardized units for instrument interfaces, so that you could develop that instrument and it could be compatible with the hopper lander, as well as the main lander, as well as the rover, for example. So yeah, that's definitely something that came up. Or even just having wireless cameras, being able to deploy a bunch of wireless cameras, setting them on the lunar surface, would be a benefit.
Yeah, and there have also been suggestions for tethered ops too, where you have a tethered piece of the rover that goes off and does that too, because certainly, obviously you need pressurized or propellant-based drones on the moon, since there's no atmosphere. But yeah,
Absolutely. Yeah. All of the do axle, JPL rover concept with the tethers, and yeah, I think there are a lot of those kinds of concepts that are definitely feasible.
great.
We didn't discuss was a lunar gravitational wave observatory.
So is that something? How can we use an arm to facilitate that?
So there could be a potential to use two arms in a setup very similar to LIGO, and it would provide a greater resolution due to less geologic activity on the moon. And it would provide a second and third, a third base station that could be used for a separate baseline measurement.
That sounds like a really interesting idea. If you're willing, it would be really great to get some insight and more insight into some of this, ConOps and specs that would be associated with that. If you'd be willing to put in a template, that would be really awesome.
Yeah, certainly.
Thanks.
Oh.
All right, so it sounds like the discussion is kind of winding down a little bit, and I certainly want to be respectful of everybody's time. If that's the case, I did want to share one final slide with you all to kind of advertise and put in plugs for upcoming workshops that we're planning. So in late or mid-November, we're planning on having a landing sites and capabilities for future CLIPS deliveries discussion. So the abstracts for that are due, I believe, next Friday. So you still have time to put in abstracts if you are interested in participating in that discussion. And we certainly encourage that. And then in late January, we're planning a workshop on inclusion, diversity, equity, and accessibility. So look for further details on that coming up. And then in the spring of 2022, we're also planning to have a heliophysics specific discussion on what science objectives we could achieve on the lunar surface for heliophysics. And details of that one are also forthcoming. So with that, I think unless people want to just hang around for 20 minutes on your own, I think we're going to go ahead and close this workshop. I really very much appreciate everybody's participation. And again, we really do invite feedback on how you think today went. It was a little bit of a different approach, but we're really trying to encourage broad participation in these discussions and make adjustments as we can, but we want to make sure that they're working. So please let us know how you think it went. And thank you all very much for participating.